All right, welcome to The Explainer. Today, we're diving into a new paper that's proposing, well, a totally different way to build AI. And it's aimed at solving a massive problem that's kind of been hiding in plain sight.
So let's just get right to it. Think about the biggest, most powerful AIs out there. Is it possible they're failing at basic logic? I mean, really struggling? Well, the answer seems to be a pretty surprising yes.
Okay, so let's really dig into this because it's a big deal. It turns out there's this hidden weakness kind of deep inside the AI giants we use every single day. You can think of it like a ceiling on how well they can actually think through tricky multi-step problems.
The paper actually has this brilliant phrase for it. They call them paradoxically shallow. And it makes sense, right? Large language models, LLMs, they're amazing with words. I mean, truly incredible. But their core design, the transformer architecture, it's flat. It has a set number of processing layers, and that fundamentally caps its ability to do that deep, step-by-step thinking, the kind of algorithmic reasoning you need for real planning or complex logic.
So, to get around this, developers came up with this pretty clever trick. You've probably heard of it. It's called chain of thought, or COT for short. And it's basically where you make the AI think out loud. You get it to generate a step-by-step explanation of how it's solving a problem. But here's the catch. It's not really reasoning. It's more of an external process, a band-aid slapped onto a much deeper issue.
And the authors of this paper, they don't mince words. They call chain of thought a crutch. A crutch. And you know why? Because it's so brittle. I mean, think about it. One little mistake in that text chain, just one wrong word, and the whole reasoning process can completely fall apart. It's not true internal reasoning. It's just a fragile, delicate pattern of words. So if just throwing more and more data and compute at the problem, making the models bigger, isn't fixing this core reasoning issue, what's the alternative? Where do you even begin to look for an answer? Well, these researchers look to the best reasoning machine on the planet, the human brain.
See, our brains are not a one-trick pony. We don't just have one mode of thinking. As the paper points out, we have this amazing two-speed system. You've got the higher-level parts of your cortex that do the slow, careful, big-picture planning. That's the strategist. And then, once the plan is set, these lower-level circuits jump in to carry out the detailed steps super fast. It's this beautiful, efficient division of labor.
And taking direct inspiration from that biological blueprint, the researchers built a new AI architecture to copy it. And they call it the Hierarchical Reasoning Model, or HRM.
So how does it work? Well, HRM basically mimics the brain's structure by having two key parts that talk to each other. The best way to think about it is like a company. You have the high-level module, that's the CEO. It does the slow, abstract, big-picture planning. It sets the overall strategy. And then you have the low-level module, that's your expert team. They're the ones who take the CEO's plan and just execute. They do all the fast, detailed, nitty-gritty work to get the job done.
Okay, now this is where the story gets really interesting. It's a classic David versus Goliath setup. The researchers took their small, brain-inspired model and pitted it against the absolute giants of the AI world. And believe me, the results are nothing short of shocking.
First up, let's talk about the size of our David in this story. The HRM has just 27 million parameters. Now, to you and me, that might sound like a lot, but in the world of AI, that is tiny. It's a rowboat next to an aircraft carrier.
And now for the Goliaths, the big commercial models we're talking about. They're built with hundreds of billions of parameters. Billions with a B. The difference in scale is it's hard to even wrap your head around.
All right, here's the next shocker, the training data. HRM learned how to do what it does from only 1,000 examples for each task it was given. Just 1,000. That is an absurdly small amount of data in the AI space. It's like learning to be a grandmaster by playing just a handful of chess games.
And this might be the craziest part of all. HRM did this with zero pre-training. It started from scratch. Think about that. LLMs are pre-trained on, well, basically the entire internet. They have this massive head start. HRM had nothing. It learned how to reason, pure reasoning, from just those few thousand examples. No cheating.
Okay, so let's get to the results. First test,
solving extremely hard 9x9 Sudoku puzzles. A real test of logic. And look at this, the state-of-the-art billion-parameter models, a big fat 0. They could not solve a single puzzle, not one. And our little HRM, trained on just 1,000 examples, it solved 55% of them. Just incredible.
Okay, but was that just a fluke? Maybe Sudoku is its one special trick. So they tried another task, finding the best path through a really complex 30 by 30 maze. And again, the results are just staggering. The big models, 0% accuracy. They got lost every time. HRM, it found the perfect path almost 75% of the time. This shows it's not a one-trick pony. This is about flexible, powerful reasoning.
But what about the ultimate test? The ARC-AG challenge. This is a famous benchmark that's all about abstract reasoning, kind of like an AI IQ test. And you guessed it, even here, our little 27 million parameter HRM, trained from scratch, comes out on top, beating its much, much bigger competitors by a solid margin.
So, what does all this mean? Look, this is way more than just a few cool benchmark wins. What we might be looking at here is a signpost, a signal that points towards a totally new direction, a fundamental shift in how we think about building intelligent machines.
And the authors themselves say as much. They believe this isn't just a small step forward. They see HRM as a promising direction for creating the next generation of AI, an AI that can finally break past the limits of today's models and achieve something like true universal reasoning.
And the best part, this isn't some abstract theory stuck in a research paper. No, they've made this thing real and put it out there for everyone. The code is open source on GitHub. You can download the pre-trained models they built. You can actually train this thing to solve complex Sudoku puzzles on a decent laptop GPU. That's incredible.
Which brings us to one last really big question to chew on. For so long, the prevailing wisdom in AI has been go bigger. More data, more compute, just scale it up. But this research, it suggests that maybe, just maybe the answer wasn't about going bigger, but about looking in a different direction. Maybe the answer has been right here, inside our own heads, this whole time. So is designing AI to actually think more like a human brain the real key to unlocking that next great leap in artificial intelligence?